So this gradient is giving you x over what? F.
So that's actually, oh, well, I did have it here. ISO. ISO, yeah, ISO. Um, okay, the gradient of a force extension graph
Yes. Of a what? Force extension graph
is K.
is K.
But that's gonna be 1 over gradient
Yes.
K divided by 4
Inverse of
of
gradient.
gradient. So 1 over gradient.
Yes.
Because it is an extension force graph and not a force extension
Yes.
graph.
So you see, on this topic, be careful which type of graph they are giving you. They would
On
want to,
force extension graph, the gradient is K. But
yes. On a force
extension
extension,
force graph, it's inverse of gradient.
yes, yes. So,
At least I understand most of it.
yes, yes. It's only the tricks that need to be, paneled through
Yeah, it needs to
practice.
be highlighted and then for me to, okay, ek moet nou die goed kyk as ek antwoord. Okay, a copper wire is fixed at a point at one end. Okay, there. Now it's gonna also come to extend. Okay. And passed over a pulley. A mass hangs from the, what's that word? From, okay, end of a wire as shown in figure 3.2. The length of the wire between the fixed end.
Let me make it visible.
And
Okay.
the pulley is 2. The pointer, what's the pointer for? It's 3.5 degrees.
Yes, the pointer is for measuring the angle from here. Because as it extends, it turns here, isn't it? So an angle is formed.
Oh, okay. Oh, I see. Okay. The length of the wire between the fixed point and fixed end and the pulley is 2.5 meters, with the mass on the wire is increased by 6 kilograms. The pointer attached to the pulley rotates at an angle of 6.5 degrees. The pulley has a diameter of 3 centimeters, is rough so that the wire does not slide over it. And that's the question.
Right?
First, for the increase in mass, show that the wire extends by 0.17 centimeters. Okay. Okay.
Is the question making sense? Let me resize here and reduce it by, let's say,
Yeah, otherwise I can't see the whole question.
yes.
Okay, yeah, that's better. That's a lot better. I'm gonna say firstly force is equals to extension times. So the force applied would be 6 times 9.81, which is, okay, now I'm gonna first write it in. So force equals kx. They want the they want the extension. So the extension would then be force divided by k. The extension is, what is the spring con? The stiffness. The spring con is actually the stiffness. So it's Newton meters. So it's mass times gravity is k. So they want, do they give us the spring constant? No, man. No, don't give the spring constant.
So what are we
Oh,
supposed to use? This,
okay.
yes,
2.5. The force times the distance equals the work. No, that's work done. What can mean the price of K? K equals F divided by X. What is K? That's not gonna help me, but I don't know what K is. But can I find K? Is there anything else I can find? K was why it increased to 6, then the degree that I did is 6.5 degrees.
How do you use that angle?
Hey,
Now you're going
yes.
back to circle measure, you see? You'd want to find what length the deflection caused. Because you have
Yeah,
this,
that's the vertical angle. That's gonna be sine.
so you have this. R is what? Radius, 3 centimeters. Then you have an angle.
That the diameter is 3, so the R is
6.5.
1.5.
What is this extension there?
Oh, what's the length of a sector of a circle, which is
Want to see from here?
R times theta, 1.5 times 6.5.
R times theta. But theta should be in radians if you are using those. We can use theta over
Okay,
360 times.
So 30, okay, no, 6.5. How do I turn stuff into radians?
I don't think you have to, but I think theta over 360, what fraction of 2 pi radius? Because circumference is 2 pi radius. So what fraction has been? Because we want to see from here 6 degrees. That's the extension.
2 pi times 1.5 is
6.5
13 over 240 pi, which is 0.17 centimeters.
yes. 2 pi times 3. 0.17 centimeters, which is this. All right.
Okay. Could you explain why you did 3 for the fraction of a times because I know that is the
Right.
the circumference of a circle is that.
Is 2 pi r, eh?
Yeah.
But what fraction of the circumference are we looking at? 6.5 degrees
Oh, okay,
of,
just angle.
yes. 6.5 degrees out of
I see.
360.
I see. Okay, now I understand. I understand.
Right. So this one we are done. All right. Where are the other questions? Let's go up. Calculate the increase in strain of the wire. Strain. Calculate the increase in strain of the wire. Strain is extension of original length. This you can do.
Calculate the increase in strain of the wire. Strain is extension divided by length. Yeah.
So we have our extension.
What is the extension then? What is the
0.17?
Oh, okay. Increase in. Oh, it's the same question.
Yes.
Okay. So we have an increase in 7, and the original length is what?
250, 2.5 meters. Which is
but we need to
50
2.5 in centimeters times 10 to the power of 2.
Yes.
Okay, so 0.17 divided by the original length 2.5 times 10 to the power of 2, yeah, is 6.8 times 10 to the power of 1, 2, 3, 4, minus 4.
Right, correct. Strain no units because it's meters over meters. Huh? So
the area of a cross-sectional area, where is that? Calculate the increase in stress. Stress equals that weird sign equals force divided by area. So calculate the increase in stress produced by okay, so force is then the stress is then 6 times 9.81,
Okay.
and then
This is what
we have what?
Okay, 6 kgs. Okay, 6 times
Yeah,
9.81.
and then that what's that?
All right.
What's the under
The question. All right.
yeah? I did not do that already. Okay, 7.9 times 10 to the power minus 7. 7.9 times 10 to the power minus 7. So the stress is then newtons divided by what's the cross-sectional area, meters squared. So the stress would then be 7.45 times 10 to the power. Wow. 1, 2, 3, 4, 5, 6, 7. Times 7.45 times 10 to the power of 7. Newton meter minus
Yes, or Pascal.
SPA.
Force
Yeah.
of area is pressure, isn't it? All right.
Pascal, sorry. Now, force of area is pressure.
Mhm. Use your answer in 1 and 2 to determine the Young modulus. The Young modulus.
Come in the Young modulus. Young modulus is stress of a strain would be 7.45 times 10 to the power of 7 divided the answer in A is 6.8 times 10 to the power minus 4 is 1.096 times 10 to the power of 11.
1.096 times 10 to the power 11. Okay. You can call it 1.1. Okay.
Yeah. Suggest how you could check that the elastic limit of the wire is not exceeded when the extra load is added. You could release the load, and the wire would return to its original length.
Yes. Release extra load and see if the pointer returns to original position or wire returns to original length. Correct?
Yeah. Oh, a glass fiber of length 0.24 meters and the area cross-sectional area section of 7.9 times 10 to the power minus 7 is tested until it breaks. The variation with load F of the extension X of the fiber is shown. Okay. And then oh, that is an extension force graph. Now, why don't they give us a force extension graph? Come on, man.
That's their trick. So hold on to it. Try to use it at every opportunity. So you must be aware of this. You know?
Yeah, yes, okay, state whether glass is ductile, brittle, or polymeric. Glass is brittle, but
Yeah.
the glass fiber seems like it's gonna be not brittle. Okay.
What is the story here?
Until it breaks max tensile strength.
It will break here.
Yeah, that means it's brittle. Yeah, brittle. That is our graph which is something is brittle. It is straight upward line net so vanaf breek.
Yes, no, it doesn't go plastic. You know.
Yeah, just goes brittle and break. Okay.
This is the ultimate tensile stress. Tensile force, I mean.
Can't I see like a cool name for it, like super conductibility or something? Because if I learn like those big words, it makes me feel smart.
Ultimate is the maximum. You know,
ultimate sounds so lame.
All right, let's go to the question.
Determine the sample of glass, or determine for the sample of glass the ultimate tensile strength. Ultimate tensile stress would be force divided by area. would be the just Newton 60 divided by the cross-sectional area. 7.9 times 10 to the power of minus 7 is 7.6 times 10 to the power of damn it. 5, 6, 7 minus 7. 7.6 times 10 to the power of minus 7.
Minus, not positive.
I got a minus.
Because you're dividing by minus 10 to the minus 7.
Yeah.
Small number into a bigger number.
Maybe
Did you
what I
put the
put it
minus there?
where?
Yeah.
Yeah. But I did it in I did not use the. Oh, there it goes. Sorry, 7. I used my calculator wrong. I did not use the fraction one. I used the like a normal divided sign.
Okay. Right. So,
Yeah, it's 7. Sorry about that. That's my fault.
yes.
Okay. The maximum strain energy stored in the fiber until it breaks. Okay, man. Now they want us to. Okay, so we have to get the area of the triangle at the top, not the bottom.
Yes.
And that is in meters minus 4. Meters minus 4. So that means the extension is in millimeters.
Extension.
Okay.
Yeah, but you must use standard units. It's good that they have given you meters. You can work with that times 10 to the minus 4.
Yeah. So I would say that half times base would be 60, because that's 60, times the 3 times 10 to the power minus 4.
Yes.
Half times 60 times 3 times 10 to the power minus 4 is 9 times 10 to the power minus 2.
Not 3.
1, 2, 3. Yeah, that could be 3. Yeah. Yeah, it could be 3. Yeah.
It'd be
Yeah, I counted wrong.
It's 3, eh? All right.